Here's another inequality in one variable, and if we notice, it's telling us it's an and. So when we think about and, that should mean that we have x in the middle in our final solution. Not always, but usually. So we have two separate equations, so I'm going to work them separately. So here I have 7 is less than 2x plus 1, so I'm just going to subtract 1 from each side. So I get 6 is less than 2x, and then I'm going to divide both sides by 2, so I get 3 is less than x. Over here, in order to get x by itself, I have to divide both sides by 3, so I get x is less than or equal to 6. So when we think about this, it's already in a nice position for us. Let's look at our number line. So number line order, 3 is smaller than 6, so we have to put 3 on the left and 6 on the right. So when I read this from the x, so x is greater than 3. Well, x is greater than 3, does not include 3, and it's greater going to the right. This is x is less than or equal to 6. It includes 6, so I color it in, and that is going to the left. So here's my x in the middle. And you can see that these here, if I were to write them, 3 is less than x, and x is less than or equal to 6, that this is repetitive. So I could replace that with 3 is less than x is less than or equal to 6, because x and x is just x, and it's in the center. That works because this is number line order. So now if I'm going to write it in set builder notation, I am not going to write it this way. I'm going to write it this way. So I have to write 3 is less than x is less than or equal to 6. When I go to look at interval notation, it's helpful for me to look at my number line. So my smallest number x can be is very close to 3, not including, all the way up to 6, including 6. So remember, this is like an equal sign that's being supported by a post, so that's how I can remember the difference between the two. So that was an AND problem. Typically AND problems get graphed coming together, and your x is in the center. Let's look at an OR problem. Here we have an OR problem. It tells us so. Again, we have two separate inequality, so we need to go ahead and solve them separately. So I want to get the 7 over with the 6 so that the k is by itself. I'm going to subtract 7 from both sides of the inequality. So this gives me k is greater than or equal to -1. Or I'm going to get the 8 over with the 3. I'm going to subtract 8 from both sides of the inequality. So that's going to give me k is less than -5. Okay, so that's my answer. Now, with ORs, I can leave the word in when I'm writing it out, when I go to do my set builder notation. The other thing is let's look at this in number line order. So k is less than -5, or k is greater than or equal to -1. Because -5 is smaller than -1, I put this inequality on the left. So when I go to graph it, -5 is on the left, -1 is on the right. Cannot be -5, just really close. K is less than. All my numbers get smaller on this side, so I graph it in that direction. Here, k can also equal -1, so I'm going to color that in. K is bigger than -1. All my numbers this way are bigger. So the set builder notation is basically going to be what I've written right here. The set of k such that k is less than -5 or k is greater or equal to -1. Just copy that right inside those brackets. Now interval notation, what I have to think about with interval is, what's my smallest number? Well, my smallest number, this goes to the left forever, so my smallest number is -infinity. What's the largest number this can be? Well, this arrow means it goes this way forever. So if I go forever to the right, I get +infinity. I have a big gap in the middle. So that big gap I'm going to represent with this big U-looking symbol. So that means when I go to write this in interval notation, I start at -infinity, but never touch it. I'm going to go all the way up to -5, but I can never be it. I can never get there. It doesn't equal. Or I'm going to start at exactly -1, and I'm going to go all the way to infinity. So that's how we write it in interval notation. So that takes care of those two problems.